All right. Last section. Test soon. Oh, that's right. You got this. Scientific notation. Let's go. All right. So scientific notation is a number expressed in scientific notation is written as a product, as a multiplication of a factor, so a number, and a power of 10. So the note times 10 to something. The factor must be greater than or equal to 1 and less than 10. Big key on that less than 10 for us here in a second. Okay, so what it looks like is a number times 10 to an exponent. And a has to be between 1 and 10. So if it's over 10, then the decimal place is going to be in the wrong place. And n has to be an integer. So example, 5 million could be written as 5.0 times 10 to the sixth. As in, I moved the decimal place over 1, 2, 3, 4, 5, 6 places. So 5.0 times 10 to the sixth. Same thing here, except we'd go the other way. So we're going to go 1, 2, 3, 4 to get 5.0, because the number here has to be between 1 and 10, times 10 to the negative fourth. Since we went to the right, that's going to be a negative number. To the left, it's going to be a positive number. So hopefully you were listening. Try this. Go. All right, one of the parts of the concept we just wrote down was the number here has to be between 1 and 10. This is not between 1 and 10, therefore it is not in scientific notation. We'd actually have to move it over 1. So this would have to go over 1 place, so therefore it would be 1.3 times 10 to the third instead of 10 to the second. All right, let's work on this one. See how the book has it here, and have a little better graphics for us here. All right, so if we're going to put this in standard form, we need to undo what's been done here. So we're going to have to move the decimal place over. So 10 to the fourth would be 10,000. So 10 with 4 zeros, or 1 with 4 zeros, sorry. So we'd multiply that over. So this means moving this over 1, 2, 3, 4 times. So move the decimal place to the right 4 times, and that would give us our number. So you can kind of skip all this part here and just say 4 spaces, and I would just take the original number, go 1, 2, 3, 4. Don't know why that just did that. And then you'd have to add the 0 to it. All right, let's put this one in standard form. So since it's a negative number, now you're going to have to move it to the left instead of to the right. So if we take 6.79 times 10 to the negative 6, we're going to have to move the decimal place over this way instead. So it's going to look like this: 1, 2, 3, 4, 5, 6 spaces. Move the decimal over 6 spaces to the left, put the decimal point, add the extra zeros you're going to need there, so that it would end up looking just like that. All right, pause this, give it a shot. All right, so let's take this first one, 2.614, and we need to move the decimal place over 6 times. So we'll go 1, 2, 3, 4, 5, 6. I need to add 3 zeros to that, and then I'll have to rewrite this with commas. So comma there, comma there. All right, so this one's going to go the other way, so I rewrite it first. I need to move it to the other way, so it's a negative number, so it's going to the left instead of to the right. So I'm going to go 1, 2, 3, 4, add my zeros, my decimal place. The book likes us to have the extra 0 there. Looking like that. All right, express this in scientific notation. Okay, so first we're going to move the decimal place over until the number is between 0 and 10. So we move the decimal place over 5 spaces. So then I'm going to take 8.0 times 10 to the 1, 2, 3, 4, 5 spaces. And it's going to be a positive exponent. Just like that. All right, write this one in scientific notation. All right, so I'm going to rewrite it out, and I'm going to move the decimal place over, because currently the decimal place is here. So rewrite it, move the decimal place over 3, 4, 5, 6 spots. So I move the decimal place over 6 spaces, so I have 1.32. That's between 1 and 10. So then I'm going to have the exponent is positive, and it has to move over 6 spaces, so it's times 10 to the 6th. All right, express this one in scientific notation, so now we're going the other direction. So I'm going to rewrite it, and I'm going to move the decimal place that way. So move it over 2. The decimal place is moved over 2 spaces, so I get 1.19 times 10 to the, since it went to the right, negative 2. Because the exponent is negative. All right, try these, go. All right, so the first one, the decimal place is here. So we're going to go 1, 2, 3, 4 spaces. So it's going to be 6.5 times 10 to the 4th. I'm going to move this one over 1, 2, 3, 4, 5, 6 spaces. So it's going to be 3.024. Use all the numbers that aren't extra zeros. Times 10 to the, we moved it over 6 spaces. This one we're going to go the other way. So we're going to go 1, 2, 3, 4. So I'm going to have 4.2 times 10 to the negative 4th. All right, this table shows planets and their distance from the sun. Estimate how many times farther Pluto is from the sun than Mercury is from the sun. So we're looking at that one and that one. So one's times 10 to the 7th, one's times 10 to the 9th. So you can see the distance from Pluto is 5.9 times 10 to the 9th kilometers, and the distance of the sun to Mercury is 5.8 times 10 to the 7th. The 7th and 9th, these numbers are actually pretty close together. So to find out how many times further Pluto is from the sun than Mercury is from the sun, we find the ratio of Pluto's distance to Mercury's distance. Since we are estimating, we can actually take this 5.9 and put it to 6.0, and this 5.8 and put it to 6.0. That'll make it easier to figure out since it's an estimating. So one of the times estimating actually helps. All right, so we put those on top of each other and use what we already know. We already know 6 divided by 6 is going to be 1. And 10 over 2, or 10 to the 9th over 10 to the 7th is 10 to the 9 minus 7, which would come out to 10 to the 2nd. So Pluto is about 1 times 10 to the 2nd times, or we could say 100 times farther from the sun than Mercury. So estimation to check the reasonableness. All right, so you try on your marks, go. Okay, so we're looking at how many times Pluto and Earth. So I'm going to take Earth here, and I'm going to take Pluto again. It's the one we're looking for. So I'm going to guesstimate these. So I'm going to take the top one and make it 2.0 times 10 to the 8th. And the bottom one is going to be 6.0 times 10 to the 9th. So 2 divided by 6 is going to be 0.3 times 10 to the negative 1. So if we move that over, it's going to be 30. Wait a minute, that'd be negative. Yep. The diameter of Mercury, Saturn, and Pluto are 4.9 times 10 to the 3rd kilometers, 1.2 times 10 to the 5 kilometers, and 2.3 times 10 to the 3rd kilometers, respectively. List the planets in order of increasing diameter. So we want the smallest planet to the biggest planet. All right, so first we order the number according to their exponents. So then order the numbers in the same exponent by comparing the factors. So first we look at the exponents, line them all up, and then we look at the factors to figure out which one's bigger. So first, Mercury and Pluto are times to the 3rd. Saturn is bigger. And then there's that one. Pluto is bigger than Mercury. Pluto is smaller than Mercury. I don't know why they did this in the first place, because 5 is obviously bigger than 2. So then we'd compare the factors of these two. This one's smaller. So therefore it's going to be Pluto's the smallest, Mercury's in the middle, and Saturn's the biggest. All right, take these numbers in decreasing order. Go. All right, so decreasing is going to be largest to smallest. So I'm going to look at exponents first. So 6.2, let's see, I got 10 to the 5th, 4th, 9th, 4th. So 9th is going to be first. So 5. Sorry, minor technical difficulties. Okay, so we'll take the biggest one first, which is 10 to the 9th. So I'm going to go 5.95 times 10 to the 9th. That one's done. This one's to the 5th. So let's say largest to smallest. 6.21 times 10 to the 5th. That one's done. All right, so these are both to the 4th. This one's a smaller factor. This one's got a bigger factor. So this one's going next. 4.79 times 10 to the 4th. And 6.21 times 10. Whoops. 2.35 times 10 to the 4th. There we go. See you in class.